the entropy of this source is probability of 0 log 2 1 over probability 0 plus probability of 1 log 2 1 over probability 1, which is equal to 1/2
So
log
it's 1.
2 of 2
It is 1.
plus 1/2 log 2 2, which is 1. So because the entropy of the source is 1, why do we not bother pairing? Why would we not bother pairing?
Because we can do better.
Can't do better, exactly. But, sorry.
So that's what I was saying, that just because we are sending using pairs is because it's the probability of one of them, like probability of 0 was 0.7.
Yes.
So if it was equally probable, then it would have been better to use just 0 and 1.
Yeah, that's right. Yeah, I mean, the big struggle here is to get a code that comes close to entropy. So if you have a code that achieves the entropy for free, which you have in this case just by sending 0 and 1, then there's no point in doing anything else.
You said zip is not as efficient as this, so.
What I mean by that is the following. This gives you the optimal prefix code. What zip does, so if for example, I had a source that was very, let me say this carefully. So let's go back to the grades example. So let's say we had a source that behaved exactly that way. All the grades were independent and they had exactly the probabilities that I gave. Then the entropy is 1/3, and this procedure gives you a code that achieves that entropy. So it's impossible to do better than that. This procedure also generally gives you the optimal prefix code. So for instance, if I had a code with these funny probabilities, or excuse me, a source of these funny probabilities, and all of the bits were memoryless, then zip would not be able to do better than the Huffman code. But sources of this type are extremely contrived. There's no, I can't think of an example of a source that would behave like this. Most sources have memory, they have funny structure that doesn't behave nicely, and on those kinds of sources where you can't specify everything up front, zip does very, very well. Whereas here, you'd have to, like for instance, think of English text. So English text can be compressed hugely. But think of all that's going on. You've got, for one thing, ASCII encoding. You've got the relationships between letters in English. You've got like sequences, like sentences, basically, which could be thought of as sequences of characters that have probabilities that can't really be specified. So zip compresses English text very, very efficiently. Whereas in order to run Huffman, you would first need to know all of the probabilities, which, I mean, just think about specifying a probability distribution over all possible sentences and all possible like ASCII encodings and all possible blah, blah, blah. It is just impossible. So this is optimal, but the complexity doesn't scale very well, whereas it does quite well for reasonable complexity. Any other questions? Okay, in the 10 minutes we have left, that's all I want to say about compression.
My last question, if you send data over the internet, is it compressed or is it just cited process?
Good question. I think if you just send a packet over the internet, it is not compressed from terminal to terminal. But I'm not 100% sure about that. So who knows? I don't know what goes on the backbone. So like if you have a proprietary backbone between two terminals that are owned by the same company and know each other, I can't guarantee that they're not doing some kind of compression. But generally, at the packet level, it's not compressed. Now individual files are of course compressed. So I mean, if you download a PDF, that contains compression.